So what do you have going on here?
All right, Hannah, now some of us already have our silver, of course, perfectly polished for the holiday. But in case you don't, do you?
What if we don't own silver? Just some stainless. Yeah. Oh, some jewelry, though. That would be good to know.
Yeah, we have some jewelry as well. We're in the kitchen chemistry lab Transform this morning with Jesse Miller, UVI Teaching Lab Specialist, REACT Program Director. All right, Jesse, we're going to take care of some of this tarnish, huh?
That's right. A friend of mine asked me a couple of years ago how to get rid of how to polish your silverware quickly, and I thought, well, that'd be a good thing to tell everybody about before Thanksgiving, so that you can polish your silver if you have silver.
Polish your silver. Does it work on sterling and things as well, or is it just
sterling silver? Yes, that's actually works better with plated stuff. Doesn't work as well because it's very thin.
Okay.
But especially sterling silver, which I think most of these things are. Okay, so it's pretty simple. The patina that you get on silver is caused, it's not an oxidation actually, well it is an oxidation, but it's sulfur, okay? Instead of being an oxide, it's actually a sulfur, and you get sulfur we have bad coal, sulfur-laden coal, so there's sulfur in the air. Also, not as much anymore as there used to be, but also foods like eggs and things like that. So if you're using your silverware to eat eggs or some of the other foods that have a lot of sulfur, they're going to tarnish, and they'll tarnish in the air also because of sulfur in the air. So it's a silver sulfide, and I actually because my silver was already polished, I actually electrochemically tarnished this particular fork, and then a friend of mine loaned me her jewelry that is pretty tarnished. So this is sterling silver as well. And in order to do this, it's an electrochemical process. We're going to electrochemically remove it. Now, a lot of the silver polishes you have out there have abrasives in it and stuff like that. So what you're doing is you're taking off a layer of this silver, and it's gone forever. What this process will do is actually change that silver sulfide back into silver, and so you don't lose anything in the process. Okay, so what you need is aluminum foil. Sorry, hold your hand. So you got some aluminum foil, and I'm going to fold this up here real quick. I think quick. And put it in the bottom of this pan.
Okay.
There we go. And then you need some hot water. The hotter the better, because these reactions work better thermodynamically if they're quick. About a half a cup of baking soda to a gallon of water, so just some. Okay. You put that in there. You got to go woo-ah when you do that. Anyway.
Okay. It's part of the process.
It is.
Just won't work if you don't do it.
And then just a little bit of salt. It doesn't take much. Okay. Now what that does is that gives us the milieu, as it were, in order to make this reaction work. So the electrons can flow from the silver to the aluminum, or excuse me, from the aluminum to the silver to get this process going. So now we got our soup here, and
our silver soup.
Our silver soup. That's right. I'm going to pour that in here real quick. Like I said, the hotter the better, which is why I waited
for a little while
to do this. So we got that on there, and then all we have to do is just place our silver right onto the, and if we got the overhead cam, you can see it already.
Oh, man.
It's happening pretty quick.
Look at that.
You can see that.
Yeah, you can see that
really well.
So what does the tin foil do in there?
It's aluminum foil. Tin foil wouldn't work.
Aluminum.
Okay.
Look at that necklace.
Yes. So what we're doing is we're transferring electrons from the silver sulfide, and you can smell the sulfur. I don't know if you can smell the egg smell.
Oh, yeah.
Yeah, it's pretty pungent. You're transferring electrons, so we have silver sulfide, and we want to go back to elemental silver. Okay, now, so we need an electron to go into the silver. So we're taking electrons from the aluminum foil and transferring it to the silver, because the silver, we call it reduction potentials and a bunch of other stuff. But basically, it would rather be, if we want to anthropomorphize it, aluminum sulfide than silver sulfide.
I see.
So we get this aluminum. And the best thing about this is, like I said, we're not taking anything off, and then you got to polish it up. Now, I kind of ruined this fork because I electrochemically did that.
Yeah.
But I could polish it back. It just take a little bit of doing.
Elbow grease.
A little bit of elbow grease.
Look at how this necklace turned out.
I know.
Right, and the necklace, yeah, it was really fast. And that.
Can we put this one in there too?
Yes, you
can. I want to see it again.
All right. Look at her. She's going to be playing with her silver tonight.
That's so cool. It just fades right away.
That's right. Now, this one I wasn't quite so sure whether it was sterling or not. And it
Maybe a little bit.
You can see it coming off a little
Yeah,
bit.
it is coming
Look
off.
at that.
It wasn't nearly as drastic
That's amazing.
as this one here was.
Your friend's going to be very happy she now has a
That's right.
polished necklace.
That's right.
All right, Jesse, we're going to be learning more from you coming up in the 7 o'clock hour, sticking with that Thanksgiving theme,
That's right.
how antacids work.
That's right.
We'll be right back.